All right, well, it is a new week in our class, July 10th. And we really only have a few more weeks in class, really only 3 more weeks, and we're done, so it's coming around. Anyway, this week is about statistics, and so you'll be reading the chapters 17 and 18 on descriptive and then inferential statistics and taking the quiz on that. And then, of course, the literature review, this is your final literature review, is due this week as well on July 15th by midnight. Or Saturday by 11:59 p.m. So it says to take your feedback you received on your preliminary literature review and update it, and add more sources to create a final lit review with the following requirements. Again, focus toward your planned research study, and a good literature review, as you remember, goes from general to specific. So it would go into general areas, talk about those, and then focus on your research study itself. APA formatted narrative writing, which many of you have been working through this entire semester. All of you have been working toward this entire semester. Studies categorized logically. Writing flows logically, systematically, and 15 or more sources of information, and an introduction, body, and summary. So again, this introduction is not about your research study. It's an introduction to the literature review itself. In other words, it's going to introduce the audience or the reader to the types of areas for the literature review and what those are going to cover. So it's going to tell you what you're going to tell somebody in the literature review. And then the summary itself will be basically a conclusion of the literature review and talk about what you have talked about. You know, what does the research say overall? What's the particular issues that are covered, and what does the research say about those issues? Basically, you tell us what you told us or what you had in the body and summarize it. So those are for the literature review that it's due this week, and you'll want to take the feedback that I gave you before on the previous literature review assignment to complete this one, and make sure again that you cite properly and use APA format. Next week there is a final proposal due, and so that means that you will be adding in everything that you've been writing this far this semester into one big long document. And so the things that you will add to this are the cover page, which I think most of you already have created, an abstract page, and the data analysis methods that are planned. And so when you think about data analysis methods, you have to think about either the qualitative or quantitative methods that you want to use. And what are the data analysis planned methods? How will you analyze the data? Now with qualitative studies, this is going to require a more extensive introduction or explanation of what you intend to plan to do with your qualitative data. With quantitative, it's a little easier. You can talk about the statistical method that you want to follow and what kind of data that will yield or what kind of results that will yield. But with qualitative research studies, that's going to take a lot more work because you have to talk about how you intend to determine what, do a content analysis or a theme analysis, and how you intend to report it and how you intend to write it up based on those things. Qualitative data takes more work, as I had mentioned before. So that's something to be aware of coming up next week, though. But for this week, it's just the literature review and these 2 chapters. I want to talk a little bit about statistics today as well. Statistics is something that you could take tons of classes about, and it's hard to cover in just 1 week everything about inferential and descriptive statistics. But I do want to start with just some introductory items about these to help you get going. So let's talk about this a bit. So descriptive statistics is what we're going to start with, and statistics are really just a set of procedures for describing, analyzing, and interpreting quantitative data. And so it's really just mathematical techniques to actually look at quantitative data in a way that helps us to see a little bit more than what we could see if we just saw the data overall. So as we look, let's see, I don't want to talk about those necessarily, but with any kind of quantitative study, you're going to have to take some time to prepare the data. So as you look at your final research proposal, you want to think about writing about this as well. What will the process be of preparing your data? So some surveys, for instance, have a strongly agree or strongly disagree. And oftentimes, that's the Likert scales that you have in surveys. Oftentimes you need to convert those into numerical data. Like maybe a 5 is a strongly agree and maybe a 1 is a strongly disagree. And so that's one way to prepare the data. And they're also usually organized by participant. So you take data from different participants and have them all in a row, perhaps on an Excel spreadsheet or something like that. And then you double check it for accuracy and prepare the data. And you actually share this process of preparation maybe a little bit when you report your research. So let's say you actually did your study, you'd report this. Here's an example, of a table. This is the participant ID over here on 001, 002, 003. There's the condition. That means whether they were in the control or treatment group. The gender, 2 or 1 is representing male or female. And then grade that they are in, and then achievement and motivation scores they have there. So each individual participant has their own row, and then they have columns for the different scores or different items that they want to know about. So with descriptive statistics, these are used to summarize the data. And basically take the data, and you might take this chart and say, what's the average achievement score? What's the average motivation score? All students came from grades 10 and 11, or whatever you might say. And you might say that students from grade 10 had an average achievement score of 78, but students from grade 11 had an average achievement score of 85. There's a lot of different ways you can describe statistics, but that is what this is calling for. Descriptive statistics, try to say that 10 times fast, is an analysis or summarization of the data. Give you overall means of the data to have you do that. And usually what you'll do is you'll calculate descriptive statistics for each item that you record scores for, and then later on after that you'll look at inferential statistics, which get more into depth. So these are some concepts though. If it's a statistic, and it's a number that you collected from your sample from your study. If it's a parameter, that means it's a number from the population itself. And there are different data types such as ratio, interval, ordinal, and categorical. You'll be reading about those. But you can look at frequencies, like how many times people responded a certain way, measures of central tendency, such as mean, median, and mode, measures of variability, including standard deviation, and variance, and measures of relationship, such as correlation, and so forth, as you look at descriptive statistics. So we won't go through all of those, but any kind of quantitative study kind of assumes a normal curve of the population, that 68% of the people will be in the middle of that curve, and then 95% will be in the larger middle, and so forth. And so you're looking at things like standard deviations from the mean, and you'll read about those as well. But basically, I did want to show that one. Hold on. One way to show data from statistics, from descriptive statistics, is to look at this. This is from a study that I have completed recently, where teachers reported those things that are largest barriers for them to use technology in the classroom. So beliefs, or not largest barriers, but largest not barriers, I guess. So the time to plan and prepare was one of the biggest barriers. People reported that, and it's 40%. So you might have this kind of a graph as a report from your descriptive statistics that you take away. You might have a graph as a result of that, where this is how people responded to the question about the greatest barriers to them. So that's one example of that. So that's descriptive statistics. Descriptive statistics, again, is just a way to summarize the data that you receive in your study. Inferential statistics, on the other hand, is a little bit different. These are analysis techniques to determine how likely results obtained from a sample are the same results that would be obtained from the entire population. And another way to say this is that inferential statistics are needed in order for you to determine if the results from your study are actually a result of whatever implementation or whatever condition the research study participants had, or if they're just happening by chance. And it's possible, a lot of things in life happen by chance, right? And so it's possible that your research study might be the result of it. It's just by chance instead of actually a result of your implementation. So here's an example of a population and a sample. Anyway, your research study, you're probably not able to collect data from the entire population of athletes in the entire world, or in the state, or even in the U.S. But you can probably get a sample of athletes that you can access to. And you're looking at statistics to help you to realize whether the sample that you collected, or the data that you collected from a sample of people, is able to be generalized to the entire population or not. And statistics are the branch of math that can help us tell that. More particularly, inferential statistics can help us to know that. So it answers these questions. Can I generalize my findings to a population? And if so, what is the probability that I can generalize my findings? Because again, the point of a research study often is to inform others of what to do, right? We make recommendations and we say, you should try this too because it worked for my population or for my sample. So statistics can help us to say whether our recommendation is a good one or not, whether it's something that happened by chance. So you'll be reading about these: the null hypothesis, the research hypothesis, and if there is a difference when we reject, if there's a difference, we reject the null hypothesis rather than accept the hypothesis anyway. There's a difference there, and tests of significance are differences due to chance or due to the actual intervention. So that's inferential statistics a bit. And you'll be reading a little bit about alpha levels as well, or p-values. Usually researchers use an alpha of 0.05 as they do these types of tests of significance. And there are different types of errors that you'll be reading as well. And then there are different statistical tests to determine differences between two or more groups. Mostly in this class we use either a NOVA or a t-test for quantitative studies. For qualitative studies, obviously this doesn't apply, right? Because these are statistical techniques to work on numbers. For qualitative studies, you're going to do content analyses, and we'll learn about that next week. But for quantitative studies, if you just have two groups and you want to determine the difference between the two, if the difference is by chance or if it is truly because of the intervention that you tried, then a t-test is probably the best way to do it. If there are more than one group, you can use ANOVA, which is analysis of variance, which is a mathematical technique, again, to determine whether the differences that exist between different groups are because of your intervention or if they're just by chance. So that's something to be aware of for those of you who are doing quantitative studies, which is most of you. Another one to be aware of too is this idea of just multiple regression or structural equation modeling. These are much deeper into things. But if you're going to do a correlation type test, then you'll want to correlate things with Pearson or Spearman correlation. So a Pearson correlation is used for those kinds of tests that have more, not categorical, but more numerical data, more ratio or interval type scales. And then a Spearman test is going to be used for the types of data that are categorical. So those are some different things to be aware of as we talk about the different types of tests. Here's a nice diagram of structural equation modeling, which is a very advanced form of statistical analysis or inferential statistical analysis, which is pretty interesting, but probably not relevant to most of us. Anyway, inferential statistics. So again, just as a reminder, this allows us to tell whether changes in a population or differences between groups on their mean are because of chance, or if they really are because of the research study that we ran and the treatments that we had on the different groups. Okay, well, I think that's about it for this week, so have a good week and good luck with your work.